Hello everyone, my name is Aaron Standard, and today we're going to do kind of a video that's more about, I guess, the operations and deployment side of things rather than software design with Akka.net. Today we're going to be talking about two-phase deployments, which is one of a few different techniques that I've used and that we recommend to our customers and users on how to introduce basically changes to your wire format without introducing any downtime. Now, as a little sort of preface before we get into the meat of today's video, if your business allows you to use downtime, so good example, maybe you have maintenance windows where the system is offline, or maybe you're in a facility where there's production windows where the system needs to be running, and then other windows where you can do maintenance. It's much easier to deploy changes to software by using downtime. It's a much easier strategy to go and execute and implement. But if you're building something like software as a service, or let's say IoT systems that have to be continuously running, then you need to take a couple of extra steps in order to make sure that changes you want to make to the way your application communicates over the network don't introduce downtime. So two-phase deployment, in my opinion, is probably the safest way of introducing these changes. You can also actually use this technique for things like rolling out changes to SQL schema if you want to. But today we're going to focus on talking about the Akka.net wire format. Now, like I mentioned, the problem here stems from needing to change the wire format. This means basically changing the bytes that are exchanged between different instances of the same application or instances of different applications, potentially, that are all working together inside the same network. So this might mean introducing new message types, adding new properties to existing messages, introducing new behaviors, new things that happen when you process a new message, or it might be doing things like changing the serializer that you're using. So for instance, you might want to move from using Newtonsoft.json to using protobuf because you get a whole bunch of compression savings on the size of the data. It's also faster, it's also more secure, etc. So there might be a lot of different reasons why you might want to go about changing the wire format inside your application. If you do this without really planning and thinking things through, what you're going to run into is downtime. You go ahead and, let's say, deploy the new version of your library, which introduces changes to the wire format, and those get propagated over the network. So I've got like a bid message type here. This is like a trading application. And this bid message type might include some new property, or it might be a totally new event type that didn't exist before. While the services running the older version of the software aren't going to be able to interpret what that means. And you might explicitly have serialization errors. That could be one thing that could occur. The other problem that you might have is that you simply lose data, where version 1.1 of the software is able to receive this message, but there's some new properties it doesn't recognize, so just discards them, since that's not built into the version of the software that's currently running here. And therefore, you might actually be corrupting data inside your system as a result of this. We want to try to avoid both of these problems. And this is what a two-phase deployment will help us solve. So a couple of prerequisites before we dive into the details on two-phase deployments. The really only super important concept we need to grasp is extend-only design. This is a versioning strategy that's been around since file formats were invented. It's how one version of Microsoft Word can open a document written in an older version of Microsoft Word. The new changes to the document format that get gradually introduced in new versions of the software still allow for the old file format to be read in its entirety. So we apply this same idea to things like SQL schemas, potentially, and we can also certainly apply it to our wire format. Doing this opens the door for having zero downtime. Without extend-only design, all bets are off. If you're making destructive changes to the wire format, like renaming stuff or deleting event types and doing all of this goofy, undisciplined programming, doesn't matter what strategy you want to use to roll it out. Downtime will be your only option if you do that. So if downtime is unacceptable for you and your business, we need to go ahead and tighten our belts and use a technique like extend-only design. So I'd recommend reading this blog post from my personal website. I'll drop a link to it in the description. This kind of talks through some of the basically best practices for doing that and how to implement it in a somewhat language agnostic way. If you want to see how to do it specifically with Akka.net, we have this video on message and state versioning in .net where we use the Akka.net serialization layer to do this. Now, this video is nearly an hour long, so you don't need to sit through all of it first if you want to follow the rest of this video. But what I would recommend doing is if you get serious about trying to implement it in Akka.net 1.4 or 1.5, the current version that's out right now, this will walk you through how to do that. One thing I also do want to mention is that we're going to be announcing our plans for Akka.net 1.6 pretty soon, our formal roadmap for that. So like and subscribe to our channel if you want to hear about that. We're going to automate most of what you see in this video, and it'll be done through source generation, basically, in the near future. But it's still good to kind of understand how that works under the covers. That's where this video will be really helpful. Now, let's dive back into two-phase deployments. So the problem that we have is when you introduce changes to the wire format and you begin disseminating it to old versions of the software, the old version of the software doesn't know what to do with it. So what we need to do in order to eliminate downtime inside our applications is leverage a Martin Fowler pattern called the Tolerant reader. The Tolerant reader is basically designing the read side of the application to tolerate a diverse range of inputs. So this means things like extend-only design or having explicit multi-version support. If you've ever built a REST API before and you've had to add, a version of v1, v2, v3 to your route on there, that is what tolerant reading looks like. That's a good example of using explicit versioning for doing that. So if you've ever had to distribute clients and some clients might be still using the v1 and you need to keep supporting that alongside the v2, REST APIs are a great way to kind of cut your teeth on doing that. We can do this exact same thing with Akka.net. In fact, that's something that we're going to learn how to do today. The other thing you can do is have an implicit versioning strategy. And I'm going to show an example of that on the next slide. The idea behind this is rather than having explicit major version numbers or anything like that, maybe we implicitly handle a change to the wire format by looking for, let's say, a property that might be null in older versions. And if that property is null, then we know it came from a version of the application that doesn't support feature X, and the way we process it might be slightly different. It's a good example of that. When we were sending those bid messages earlier, maybe before we assumed all trades would all be denoted in dollars. Well, if we wanted to add multi-currency support to our application and we introduce a new currency code field, if we see that currency code is null, we should assume that means dollars. That came from a version of the application that only dealt in dollars. But if we also support euros and pounds, we might go ahead and handle those operations differently because they might correspond to totally different accounts inside our system. An implicit versioning strategy there would be to substitute a null value with USD. That is a totally valid, workable production grade strategy. So this is an example of where we've done some implicit version tolerance inside Akka.net. Now, this comment is what I want to draw to your attention to. We noticed when we were making some pretty major changes to Akka.Cluster sharding between Akka.net 1.4 and 1.5 that long and the short of it, we basically did something a little messy in 1.4. Therefore, we needed to introduce a way to make that forwards compatible 1.5. This is how we went and did that. We take a look inside the DData serializer for this specific data type, the last write wins register. And in the event that we have backwards compatibility turned on and the type name for the payload being transmitted corresponds to this old data type, we go ahead and we make sure we keep using that old data type. This was designed to go ahead and make sure that Akka.net 1.4 and 1.5 could basically cooperate side by side with each other in the same cluster with no downtime. Exactly what we're trying to do generically in this video. Now, the process by which we want to introduce this tolerant reader and the changes to our wire format is through what's called a two-phase deployment. The idea behind this is pretty straightforward. We're going to do two different deployments to try to address two different parts of the problem. This will allow us to not have downtime for either deployment. The first phase is we introduce the tolerant reader first. We do that before we introduce the code that produces the new events or the new properties or the new fields or whatever the case may be. We need to test our reader and make sure that it works with both the new and old wire formats concurrently. The trick to having zero downtime is to support multiple versions of your wire format concurrently. In a REST API, we just do this by adding new routes. In Akka.net, we do this by making sure our serializer has the ability to recognize changes to the wire format and adjust to them, or we use different serializers for different versions of our wire format. That would also be a perfectly valid strategy for handling this. This is going to prevent data loss during upgrades. We're not going to drop messages. We're not going to accidentally lose data when any of this is happening. This will prevent data loss during upgrades if we validate that this can be done. Step 2 is we introduce the production of new event types. So after all of the read side code has been fully deployed, now it is safe for us to go ahead and introduce the write side code, the production of new event types. So with the Tolerant reader already in place, all new event types should be handled correctly from the get-go. So this should be pretty seamless, provided that we've done our work. But a key question that you're going to have if you're a practiced engineer is, okay, well, I understand how to introduce a Tolerant reader. That's just changing our serializer inside Akka.net. But how do I actually disable the production of new events until I know that we're ready? Well, the answer is we're going to use feature flags. Feature flags are yet another pattern for being able to toggle certain functionalities inside the application on or off explicitly via configuration. Now, you don't need to run out and get a Launch Darkly subscription or anything crazy like that. All we need to do is introduce a little bit of configuration. So in this case, inside our DData serializer I showed earlier, we have a setting we look for in Hocon where we say, do you want backwards compatibility mode enabled? If you do, we go ahead and use this to toggle it. If you don't, we disable it. By the way, I should mention, this is actually a read side feature flag. I'm going to show you a write side feature flag using Phobos. Now, Phobos is our product that we sell that basically introduces open telemetry tracing and metrics to Akka.net actors. The reason why Phobos is a good candidate for talking about feature flags is because one problem that Phobos introduces is that it actually wraps all of your messages going over the network in Akka.Remote inside an envelope that contains tracing headers. And that's what we use to basically perform correlation for activities that occur in process A with activities that it triggers in process B. So this is an example of something that might introduce a breaking wire format change. Let's go ahead and take a look at our code and see what we can do to make sure that this all works spick and span. Okay, so just to give you an idea of what we're going to do today, we're going to install Phobos into an application that we have in kind of a staging environment inside our test lab here at the office. Phobos is our open telemetry integration for Akka.net, so it's basically a little add-on, and it does change the wire format when you're using Akka.Remote and Akka.Cluster. It introduces an additional, let's say, wrapper layer that includes all the tracing headers we need in order to perform correlations inside our distributed tracing system. So for instance, I'm using Seek right here, and I'll go ahead and show you the URL this corresponds to. But just to give you an example of sort of what that looks like over the wire, we have two different services here. In fact, I'll show them to you. We have NuGet Updates, which is a bit of a work in progress. We hope to get it out into the public in the next few months. But basically, it's a little service for being able to keep track of all of your NuGet packages that you want to receive updates to. The UI is still very much in a prototype phase here, so give me some grace on that subject. It allows us to go ahead and basically keep track of updates for our packages. We basically get like a personalized email digest once a day or once a week, depending on how our settings are set and also how frequently these packages get updated. We have this administrative portal on the back end right here, which, this is just using kind of the default ASP.NET theme for the time being, where I can see all the different packages in our system. I can take a look at the most recent version and how long we've tracked it. Then if I click into here, I can go ahead and see when was the last time we actually scanned this package for changes. And I can see that I personally kicked off a few scans earlier. Well, if I kick off one of these scans where I run a fast check or a slow check, that is going to create this type of trace right here, where the admin portal is going to receive this HTTP post request via the web UI. That's going to go ahead and cause it to kick off this little ask operation here. We're going to go ahead and try to get a scan accept result back. And this is going to cause us to go ahead and basically transmit this request scan if possible message over the wire between the NuGet Updates admin portal and the NuGet Updates service. Now this operation completes and we get our HTTP response back in the first 200 milliseconds or so. But if we scroll down a bit further, you can see all this actor activity. This also includes these HTTP requests right here, which if I zoomed in on those, this is actually us, in fact, you can see it here, querying the NuGet.org API. So this is performing that real deep scan that we were looking at. So Phobos goes and gathers all this information for us. Well, what I've already gone ahead and done is I had Phobos previously installed in this application. I've uninstalled it and deployed it, so we're no longer getting new traces. To enable Phobos and basically get the Tolerant reader deployed, so this is a little bit of Akka hosting code. Both the NuGet updates client UI and the admin portal share this configuration here, which is a best practice that we talk about in some of our videos on Akka.NET application management. What I've done here is I've had the Phobos NuGet packages installed, but they're not configured inside our actor system at all. So to configure it and enable the Tolerant reader, I would go ahead and enable this configure actor telemetry. And this is the method built into the Phobos NuGet package that actually turns it on, this with Phobos line down here. And the thing that causes us to produce problems with the wire format is actually going to be our tracing. Metrics doesn't, basically our metric system, we don't care about that. None of metrics don't go over the wire, but tracing does. So I have in our settings class, I have the ability to pass in this little custom enum here that specifies what level of verbosity we should have inside our tracing system. And by default, we run with, I think, user only enabled. Well, I have gone ahead and basically, the way I'm essentially disabling this feature flag so we can safely introduce these wire format changes is if I scroll to app settings.json, I have my Akka settings right here. I've got some ASP.NET, Azure AD settings. This is all junk and localhost stuff, by the way. This is just so I can do local development, no problem. But if I scroll down here, we have our Akka.NET settings, and I have basically specified that we want to have Phobos disabled. This means that we're not going to propagate anything over the network. So for the time being, one of the things I can go ahead and do is I am going to go ahead and do a deployment here where we're going to get Phobos deployed with tracing disabled, but the serializer definitions that Phobos uses to interpret those trace messages, by uncommenting this line, that'll enable those. So let me go ahead and kick off a deployment into our Kubernetes cluster real quick, and then we're going to do a little test where we enable tracing in one service but not the other. All right, well, as you can see here in my admin service, I've got the tracing mode set to user only. So this is kind of what like the second part, the second phase of the deployment would look like. We might go ahead and introduce these changes to services one at a time. And the reason why I want to show this, only upgrading one service initially, is that the other service, the regular NuGet updates web UI, should be able to process these traces without throwing any errors. So if I take a look at our tracing system right now, I'm looking at traces from NuGet updates and from the admin portal that come from Phobos. I've got a live tail going. It's 3:57 p.m. We haven't seen any since about 10 minutes ago, 5 minutes ago. So there's no new traces being produced. I can go ahead and walk around the website and all this will work. And let me go ahead and get the admin portal up and running. Let's see, admin staging at NuGetUpdates.com, change feed. I can go down here, run a check. That should normally kick off a flurry of actor activity, and boom, we don't see anything. Phobos tracing is still fully disabled. So I'm going to go ahead and enable it. And then down here, we're going to go ahead and roll out a new update to our Kubernetes cluster. And if I take a look here on K9s, I should go ahead and see that the admin portal is basically being terminated and recreated. It should be done momentarily. This goes pretty quick usually. And now we're starting to see a flow of traffic again behind the scenes here. Even with just one instance of the process running, none of the NuGet update staging stuff should be working. So if we take a look here, we're starting to see some of our events perk up. That all looks pretty good to me. Yep, petibridge.command, got a couple of other little things going. Oh, looks pretty hunky-dory. Okay. So I'll go ahead and let that chew for just a minute here. Now let's go to our change feed and let's go and scan for, I don't know. Let's take a look at Akka streams. We haven't done an update on this one. Maybe we'll do Akka.Remote. Let's go ahead and run a slow check on this one. Go ahead and kick that off. And if we take a look in here, oh boy, we can see a whole bunch of stuff getting kicked off. Let's look at this trace right here. So in 141 milliseconds, this post request completed, and we can see this ask operation here. And we can see a couple of actors that got spun up inside the NuGet updates portal. That is all happening basically inside the admin portal only. We are not seeing any traces show up at all on the normal NuGet update UI. In fact, if I get rid of Phobos here and I go to Take a look at errors. Let's go ahead and pull that up. We have some unhandled messages, and this is from like 2 hours ago. So we don't have any problems that are showing up. Any logs from Akka.net would actually show up down here and would look something like this. This is totally unrelated to our test. This happened hours ago, like 3 hours ago. So looks like there's no serialization errors, no problems of any kind. Now I'm going to go ahead and finish the deployment and roll out the update to the admin side, and everything will just work. And this is how you complete a two-phase deployment. Okay, so I've got the Phobos settings for the web portal now set to user only as well. Let me go ahead and roll this out. Go ahead and run my little script here. This will take a little bit longer to roll out, but at this rate, everything has now been fully configured. We're able to go ahead and basically send traced messages over between the admin portal and the NuGet update UI, even if we basically don't have tracing enabled. We're basically turning these feature flags on is what we're doing now. Now the deployment can be finished. Normally I would do these all in one go. I would just go ahead and roll out updates to all services all at once. But basically you could also do it in a staged manner, redo services one at a time. There might be some advantages to doing it that way. There's nothing inherent inside Akka.net that'll stop you from doing that. Okay, it looks like NuGet Updates 2 is now running the latest code. And then we'll go ahead and wait for NuGet Updates 1 and 0 to also get updated. That way we know everything will show up. Okay, so there we go. Everything's working again. Now I can go ahead and run my slow check here for Akka.Remote, reload. And let's take a little look. Let's get rid of the errors. We'll just look for Phobos traces. Let's see if I can find that. Here we go. Look for Phobos traces. Let me get rid of the view here. And look at this. We go ahead and I can see our little info log. Let's go ahead and see if I can show that. And voila, we have our whole big trace all over again. And we can see the network calls being made across the wire. And there you go. That is how you successfully complete a two-phase deployment. Thanks for watching. Please don't forget to like and subscribe. Thanks for your time.